Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a straight line is going on and we are successfully finished with the graphical section. Okay, but in that section, so one more important concept is there, that is a velocity versus displacement graph and the acceleration versus displacement graph. Okay, so in a previous lecture that we have discussed about a displacement versus time graph. The slope of graph of displacement versus time gives a velocity. The slope of graph of velocity versus time gives acceleration. Okay, so in case of velocity versus time graph, the area covered by the slope gives a displacement, and in case of acceleration and time graph, the area covered by the slope gives what? Change in velocity. These things that we are discussed in a previous lecture, that is graphical section. So one more part is there, so this is also an important part. Shall we start the session? Right. So my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Right? Okay. So what is the chapter going on? Motion in a straight line. Straight line. Okay. So what is the concept today that we are going to discuss? So that is velocity versus displacement graph. Velocity versus displacement graph. Okay. Right. Have a look. Right. So we know that the general definition of acceleration or the general formula for acceleration. So what is acceleration? The rate of change of velocity dv by dt. Okay. So now I'm just multiplying and dividing this equation with dx. Okay. I'm just multiplying and dividing this equation with dx. So as we know, dv by, I'm just writing dx here, into dx by dt, dx by dt, where x is nothing but what? Displacement. X is nothing but what now? Displacement. Okay, are you getting? Right, very good. So dv by dx into, what is this? Dx by dt. X means what? Displacement. The rate of change of displacement is called what? Velocity. The rate of change of displacement is called what? Velocity. So just bring this velocity to this side and it becomes a by v is equals to dv by dx. A by v is equals to how much? Dv by dx, or it can also written as dv by dx is equals to what? A by v. Can I write like this? Okay, sir. Thank you, sir. Very good, sir. Okay. So what is the meaning of dv by dx? What is the meaning of dv by dx? So dv by dx means the slope of the slope of graph of the slope of graph of v versus x, v versus x gives the slope of graph of v versus x gives what? A by v, gives a divided by v. A means what? Acceleration. V means what? Velocity. Okay, that means if you are draw the graph for, if you are draw the graph for velocity versus displacement, velocity versus displacement, then the slope, let us consider the graph is like this. Like this. Okay, so I wanted to find the slope at any point p. Okay, now this point p is at a distance of x1 on x-axis. That means displacement of this point p is x1 and the velocity of this point p is v1. Okay, so how to find the slope? Just draw the tangent from this point p and it gives what? Slope. So what is this slope? This slope represents what? A by v. This slope represents what? A divided by v. Are you getting? Any doubt? Okay, very good. So note. So what we got? Dv by dx is equals to a by v. Okay, so if a is constant, if acceleration is constant, if acceleration is constant, then so dv by dx is inversely proportional to velocity. Dv by dx is inversely proportional to what? Velocity. That means if slope, if slope increases, that means dv by dx increases, then velocity of the object is decreases. Are you getting? Right. if slope decreases, if slope is decreases, then velocity of the object is increases. Then velocity of the object is increases. Are you getting me? Any doubt? Okay, write down. Pause the video and write the notes. Let's we do one example problem. 3, 2, 1, go. Right. So have a look. An example problem. Okay. Right. A graph is given like this. So this is velocity and this is a displacement. Okay. So initial velocity of the object, let us say 20 meter per second. So velocity is in meter per second and the displacement is in meters. Okay. And the displacement of the object after some time t, let us say 50. How much? 50. So what they are asking, find the acceleration of find the acceleration of an object when displacement when displacement is 0, when displacement is 0. So this is a given question. So they are given one graph. Okay, so this graph is for what? Velocity versus displacement. So what they are asking, find the acceleration of an object. We have to find the acceleration of an object when the displacement is 0, when the displacement of the object is 0. Okay, have a look how to solve. So one thing you should remember. So what is that? Whenever they are given graph for velocity versus displacement, whenever they are given the graph for velocity versus displacement, just you have to write like this. So the slope of graph of v versus x gives a by v. Gives what? A by v. What we have to find? We have to find acceleration. Okay. So velocity of the object we have to find from the graph, and the dv by dx is nothing but what? Slope. So now I'm going to find the slope. So what is slope? Slope is equals to what? dv by dx. This is equals to, one thing is clear from this graph. Have a look. So this is what? Origin. This is what? Origin. So initial position of the object is at this point. Let us say this is a point A and this is a point B. Okay. So at a displacement x is equals to 0, at a x1, let us say this point is x1 is equals to 0, then at this point velocity of the object is how much? v1 is equals to 20 meter per second. Are you getting? I'm just writing the coordinates of point A. Okay. So at x is equals to 0, initial position, at x1 is equals to 0, the velocity of the object is how much? 20 meter per second. Right. If you comes to second point at A, at B, at point B, so x2 is equals to how much? 50. And v2 is equals to how much? At this point velocity of the object is equals to how much? 0 meter per second. So this is what? 50 meters. This is what? 0 meters. Now the point A is what? 0 comma 20. Point A is what? 0 comma 20. What is point B? What is point B? 50 comma, are you getting? 0. 50 comma 0. Are you getting ma? So simple coordinate geometry. Okay. Right. So what is the point here? We got initial point A is equals to 0 comma 20. What is the point B? We got B is equals to 50 comma 0. Are you getting? Okay. So let us say this is point x1 y1, x2 y2. Then the slope of this graph, dv by dx is equals to, we can write y2 minus y1 by x2 minus x1. Are you getting? In a slope concept, I told you each and every point. Okay. Right. Then slope is equals to dv by dx is equals to, what is the value of y2? 0 minus what is the value of y1? 20 divided by what is the value of x2? 50 minus what is the value of x1? 0. So this is equals to minus 20 divided by 50. So 0 0 cancel out. Then the slope dv by dx is equals to, we got how much? 2 by 5. 2 by 5. Okay. So now we have to find the acceleration. Let us say this is equation number 1. Substitute dv by dx in equation 1. In equation 1. So have a look. What is equation 1? We have a by v is equals to dv by dx. So a is equals to, if we went to that side, it becomes v into dv by dx. So this is equals to v into, what is dv by dx? Minus 2 by 5. So this is the value of acceleration. So we have to find the acceleration of the object when the displacement is 0. When the displacement is 0. Have a look from the graph, from the figure, from graph, at displacement. When the displacement is 0. When the displacement of the object is 0. So what is its velocity at a displacement s is equals to 0? Its velocity is equals to how much? 20. Just substitute this 20 here. So a is equals to 20 into minus 2 by 5. 5 ones are 5 fours are. So a is equals to, we got minus 8 meter per second square, and this is our answer. How much? A is equals to minus 8 meter per second square. Are you getting? Okay. So why we got minus sign here? This means this is retardation. This is what? Retardation or negative acceleration. That means with respect to the time, the velocity of the object is decreases. So change in velocity will be decreases. Then acceleration tends to negative. So when the acceleration of the object becomes negative, then it is called what? Retardation. Okay? Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right, have a look. I'm going to take the second example. Okay, example number 2. At this time, instead of v, I'm taking a v square on y-axis in meter per second. Same along x-axis, I'm taking the displacement x. The slope is the same. That is 20 and 50. So this is origin O. Question is same. Find the acceleration. Find the acceleration of the object when displacement is 0. When displacement is 0. Right. Have a look. The previous question and this question both are same, but in a previous question along y-axis we have taken only velocity, but at this time we have v square. So remaining data is same. So pause the video and try the solution. 3, 2, 1, go. Have a look. So this is what the graph of v square versus displacement. That means slope is equals to dv square by dx. Right. So here we have dv square by dx. Now I'm just multiplying and dividing this equation with dv. I'm just multiplying and dividing this equation with dv. So have a look. So dv square divided by, so bring this dv to this side, bring this dx to that side into dv by dx. How is my English? Good now? My English is copied from British English. Okay, thank you. So here we have a d by dv of v square. Have a look. D by dx of x square. D by dx of x square. What is its value? Differentiation of x square is how much? 2x. Here we have a d by dv of v square. What is its value? 2v. Its value is how much? 2v. Just here I am multiplied and divided with a dv. So have a look. D by dv of v square, it becomes 2v into dv by dx. Are you getting? Right. So just take a look. So 2 into, I am just writing this equation as v into dv by dx. V into dv by dx. What is v into dv by dx? In a previous example, we are solved v into dv by dx. What is that? Acceleration. So slope is equals to, we got how much? 2 into acceleration. 2 into acceleration. So from this, we got acceleration is equals to slope divided by 2. Slope divided by 2. So we know that how to find the slope. So slope is equals to d square v by dx is equals to, are you getting? So v into dv by dx is nothing but what? A. So acceleration is equals to dv by dt. Okay, just multiply with dx divided by dx. Okay, so dx by dt is nothing but velocity. The rate of change of distance is called velocity. So dv by dx. So v into dv by dx, v into dv by dx is nothing but what? Acceleration. Are you getting one? Slope d square y by dx is equals to how much? Y2 minus y1 by x2 minus x1. Okay, so have a look. Already we got this point. A is equals to how much? 0 comma 20. At this point 50 comma 0. In a previous question we had solved. Okay, so A is equals to how much, ma? 0 comma 20. B is equals to how much? 50 comma 0. Are you getting any doubts? Same thing I'm repeated, but here we have slope divided by 2. Acceleration is equals to how much? Slope divided by 2. So this is what? X1 y1, x2 y2. Then slope is equals to d square y by, sorry, d square v by dx is equals to y2. What is y2? 0 minus y1 20 divided by x2 how much? 50 minus 0, that is equals to minus 20 divided by 50. 0 0 cancel out, and we got a d square v by dx is equals to minus 2 by 5. Just substitute in this equation. Let us say this is equation number 1. Substitute slope. What is this? This is what? Slope. D square v by dx is equals to how much? Slope is equals to, substitute slope in a equation 1. So what is equation 1? We have acceleration is equals to slope divided by 2. What is the value of slope we got? Minus 2 by 5 into by 2 is there, 1 by 2. 2 to get cancelled out, minus 1 by 5 meter per second square. So this is our answer. Are you getting? Easy one, na? So the graphs are very easy, na? V versus x. So whenever they are given v versus x, how to solve the question? So the slope of graph of v versus x, dv by dx gives what? A by v. Gives what? A by v. Okay. So likewise, you have to take the slope. After that, you have to substitute in this equation. You will get the answer. Okay. Right. So pause the video and write the solution. 2, 1, go. Right. So let us discuss acceleration versus displacement graph. Acceleration versus displacement graph. Okay. Right. Right. Have a look. I'm taking the same equation for acceleration. What is that? The rate of change of velocity dv by dt is called what? Acceleration. I'm just multiplying and dividing this equation with dx. So dx divided by dx. Okay. So have a look. Here we have dx by dt. dx by dt. What is the meaning of dx by dt? The rate of change of displacement is called velocity. Again we have dv by dx. dv by dx. So I'm just writing this equation as v dv, v into dv, v dv. This is equals to a into dx. This is equals to how much? A into dx. So just integrate this equation on either side. Integrate above equation on both sides. So if we integrate, we will get like this. V into dv is equals to integration of a into dx. Integration of a into dx. So have a look. The graph for acceleration versus displacement is like this. So this is acceleration and this is displacement. So the graph is like this. The graph is like this. Okay. So at any particular instant of time, so the position of the object, let us say x1 and the x2. x1 and the x2. What is integration of ADX gives? Integration of ADX gives this term. Integration of ADX gives the area covered by, already in an integration topic I explained. Okay, so how we will get an area? So why we have to take the area covered by the graph? What is differentiation gives? What is integration gives? All these things we are discussed in a 2 lectures. One is differentiation and another one is integration. So if you are watched that video, then now you can understand easily. Okay, right. So this term integration of ADX gives what? The area covered by slope or graph. Area covered by slope or graph. So have a look. At any particular instant of time, the position of the object, here I am writing. So integration of v dv is equals to integration of a into dx. Okay, so this is what area covered by the slope or graph. So integration of a dx, at any particular instant of time, the position of the object is x1. At this time, the velocity of the object, let us say v1, and after some time t, the position of the object is x2, and at this time the velocity of the object is v2. How much? v2. Okay, so now this integration a dx gives what? Area covered by the slope or area under the graph, whatever it is. So this is the formula to solve what? Acceleration versus displacement graphs. Okay now, so have a look. Here we have integration of v dv. What is the value of integration of v dv? V square by 2. We have the limits. What are those? v1 to v2, that is equals, if a is constant, if acceleration of the object is constant, a means what? Acceleration. Okay, so then a comes outside from the integration, and we have dx from x1 to x2. So v square by 2, I'm just writing 1 by 2 outside. So we will get upper limit v2 square minus v1 square, that is equals to a into integration of dx. It becomes x, limits are x1 to x2. I'm just writing this equation as v2 square minus v1 square divided by 2 is equals to a into x2 minus x1, x2 minus x1. So finally v2 square minus v1 square by 2 is equals to a into, so this term, what is this term shows? Area covered by slope or graph. Area covered by the slope or graph. So likewise we have to solve the problems when we get acceleration versus displacement graphs. Are you getting? Okay, so pause the video and write the notes. So integration of v dv is equals to integration of a dx. What is the integration of a dx gives? The area covered by the slope or graph. So let's we solve an example question. Have a look. Example. Okay, so pause the video and write the notes. Till here write down. 3, 2, 1, go. Right, so have a look. So this is the example question for acceleration versus displacement graph. Okay, so have a look what they are given. Referring to ax graph, they are given one ax graph. Have a look. Find the velocity when the displacement of the particle is 100 meters. What they are asking, we have to find out velocity is equals to how much? Velocity is equals to how much when the displacement of the particle is equals to how much? 100 meters. They are given. Assume that initial velocity is 0. So u is equals to how much? 0. Initial velocity is given how much? U is equals to 0. So in a concept, we have discussed that whenever acceleration versus displacement graph given, what is the formula we have to use? So integration of v into dv is equals to integration of a into dx. So this is the formula we have to use. Are you getting now? Right. So what is the initial velocity of the object given? 0. What they are asking? They are asking to find the final velocity. So the final velocity of the object is v. Initial velocity is 0. Final velocity is v according to given question. So what is integration of a dx? What is the meaning of integration of a dx? The area covered by the slope, by the slope or graph, whatever it is. Okay, slope or graph. So we have to find the area covered by this graph. Eta displacement is equals to how much? 100. Displacement is equals to 100. Have a look. In this given graph solution, in this given graph, the 100 is in between 50 and 150. 100 is in between 50 and 150. Have a look. This is what? Displacement. So we have to find the area at s is equals to 100 meters. So here I am taking the point 100 displacement. It is in between 50 and 150. Have a look. When the displacement of the object is 100 meters, at that time I am taking the acceleration of the particle is a2. Acceleration of the particle is a2. So I'm just expanding this line. So at this time, at this point, I'm taking the acceleration of the particle as a1. Acceleration of the particle is a1. Now what we have to find? Just we have to find out this area covered by the graph. Have a look. What we have to find? We have to find this area covered by the graph. Okay. So this area gives what? Integration of ADX. That area gives what? Integration of ADX. So have a look. I'm just taking the points. I'm just finding the points. Have a look along x-axis. Let us say this is a point A and this is a point B. This is point C and this is what? Point D. Okay. So what is point D? We have along x direction coordinates 150, comma along y direction the coordinates is how much? 6. If you comes to point C, what is the x coordinate for C? 100. And what is the y coordinate? A2. Are you getting? For B, what is x coordinate? 50. What is y coordinate? 3. In case of A, what is x coordinate? Is 0. What is y coordinate? That is A1. Are you getting ma? Any doubts? I am just writing the coordinate points for A, B, C, D points. Have a look. What is A? The A point is at 0 from x-axis and A1 from y-axis. Point B. What is point B? 50, comma 3. Are you getting? Easy one ma. Okay, simple geometry. So what is point C? 100, comma A2. What is point D? 150, comma 6. 150, comma 6. Have a look. One thing is clear from the graph. Whatever the slope they are given, that is a constant slope. What is that? That is a constant slope. The slope is a constant. The slope is a constant. That means have a look. From the positive x-axis, every point on the slope is at a same angle. From the positive x-axis, every point on the slope is at a same angle. That's why the slope is what? Constant slope. Okay, already we have discussed more. Right. So from this condition, I'm taking the slope of BD. Slope of BD is equals to slope of BD is equals to slope of BC. Slope of BC. Can I write like that? Because slope is constant everywhere, the value of the slope is same. So how to find the slope? So y2 minus y1 by x2 minus x1, that is equals to BC, y2 minus y1 by x2 minus x1. So have a look. BD, BD. In case of BD, x1, y1, x2, y2. So BD is equals to y2 minus y1. 6 minus what is y1? 3 divided by x2. What is x2? 150 minus what is x1? 50. Are you getting? That is equals to, in case of BC, here B is there, here C is there. X1, Y1, this is what? X2, Y2. So that is equals to Y2 minus Y1 divided by X2. What is X2? 100 minus X1. What is X1? 50. Are you getting more? I'm just writing the equation for slope. Okay. So BD is equals to BC because everywhere on the every point on the slope is at a same angle from the positive x-axis. That's why slope is same for every point. Okay. So that's why I'm taking slope of BD is equals to slope of BC. So this is the formula. So first point is B and the next point is D. That's why I'm taking this is x1 y1, this is x2 y2. So here first point is B. That's why I'm taking x1 y1. Second point is what? X2 y2. Are you getting? Right. 6 minus 3. 3 divided by 1 minus 150 minus 50. 100. This is equals to A2 minus 3 divided by 100 minus 50. 50. So 50 ones are 50. 52 is 100. 3 by 2. 2 ones are 2. 2 ones are 2. 0.25 is 10. So 1.5 is equals to A2 minus 3. If 3 comes to this side, it becomes plus 3. 1.5 plus 3. So A2 is equals to 4.5 meter per second square. So the value of A2 is equals to how much? We got 4.5. Next we have to find the value of A1. We have to find the value of A1. Have a look. A, B, A, C. The slope of AC is equals to slope of AB. I am taking this condition now. So what is that? The slope of AC is equals to the slope of AB. Are you getting me? So this slope AC is equals to the slope of AB. So what are the points of A? X1, Y1. At this time, B becomes X2, Y2. So AC, A is the first point and C is the second point, X2, Y2. So the slope formula, what is that? Y2 minus Y1 by X2 minus X1, that is equals to, again, Y2 minus Y1 by X2 minus X1. So AC, AC, Y2 minus Y1, Y2 minus Y1, that is A2 minus A1, A2 minus A1 divided by X2 minus X1, 100 minus 0. So next, AB, AB, Y2 minus Y1, 3 minus A1 divided by X2 minus X1, 50 minus 0. Okay, so right. So A2, what is the value of A2 we got? A2 is equals to how much? 4.5 minus A1 divided by 100 is equals to 3 minus A1 by 50. So 50 ones are 50, 52 is 100. So 4.5 minus A1 is equals to 2 into 3 minus A1. Okay, and just bring this 2 to this side. Okay, right. 4.5 minus A1, this is equals to 2 3 is 6 minus 2A1. Bring this minus 2A1 to this side. It becomes plus 2A1. Already here minus A1 is there. So 6. Bring this 4.5 to that side. It becomes minus 4.5. Are you getting? Simple mathematics, right? So 2A1 minus A1. A1. 6 minus 4.5. 1.5 meter per second square. So at this time, the value of A1 is how much? 1.5 meter per second square. Now I wanted to find the area covered by the slope. How to find? Have a look. The graph is like this. La 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 la. This is the area we have to find. Okay. La 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 la. So this is A2. This is A1. Okay. And this is 100. Okay. 100. A2, A1. 100, A2, A1. What area we have to find? We have to find this area. Okay. Are you getting mark? Okay. So from the origin, this point A2, from the origin, this point A2 is at 4.5 meters meter per second square. So this height is how much? 4.5 meter per second square. And A1 and the A1 from origin, the A1 is at 1.5 meter per second square. This is how much? 1.5. This small line is how much? This area, this length, how much? 1.5 meter per second square. The total length is how much? 4.5 meter per second square. If this is 4.5, then opposite side is also 4.5. Are you getting now? Okay, so this is how much? This is 100 meters. This is what? Acceleration versus displacement. Have a look. What shape it is? Which shape it is, ma? So this is what? It is a trapezium. Trapezium. What is that? Trapezium. So what is the formula for area of trapezium? Area of trapezium formula is how much? Half into sum of parallel sides. Sum of parallel sides into height. Into height. Are you getting? Okay, very good. So have a look. This is equals to half into sum of parallel sides. Have a look. This is 1.5. This is 4.5. Sum of parallel sides is equals to how much? 1.5 plus 4.5 into what is the height of the trapezium? 100. Okay. So 2 ones are 250s are. So this is equals to 4.5 plus 1.5. 6 into 50. 6 into 50 is 300. So the area covered by the trapezium is equals to how much? 100 meters square. How much, ma? 100 meters square. Are you getting? So this is in the shape of trapezium. Okay. So what we have to find? Area covered by the slope. So this is the area covered by the slope. So area of trapezium is equals to half into sum of the parallel sides into height. So these two are the sum of parallel sides and this is the height of the trapezium. Just we got how much? 100 meters square. So just to substitute here, I'm just going to rough this part. Okay. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right, have a look. Integration of v dv. What is the value of integration of v dv? V square by 2. So initial velocity is 0, final velocity is v. So what is the area covered by the graph we got? 300. Okay. So upper limit minus lower limit. So v square by 2, upper limit minus lower limit is 0, is equals to 300. So v square by 2 is equals to, finally we got how much? 300. Okay. So if 2 went to this side, it becomes v square is equals to 600. Square went to that side, it becomes root 600. Okay. So what is root 600? So we can write 6 into 100. We can write 6 into 100. It becomes, 100 comes from root, it becomes 10. So our final answer is how much? 10 root 6 meter per second. So likewise, you have to solve the problems when you got on acceleration versus displacement graph. Okay. Are you getting any doubts? Right. So pause the video and write the notes. If you are not understood the lecture, once again go backward and listen. You can understood clearly. Okay, right. Pause the video and write the notes. 3, 2, 1, go. Right. So this is the end of the today's lecture. So small concept it is, velocity versus displacement graph and acceleration versus displacement graph. I hope that you are enjoyed the lecture and you are understood the lecture. Okay. So this is the end of the today's session. We will meet on a next lecture. Stay tuned. This is Rakesh Kaniyanti signing off. Jai Hind.